today to come. My name is Rob DeFeo. I'm a startup advocate here at AWS. And what that means is I spend most of my time helping startup founders and CTOs build their technology and their products. So for today's talk, we're just going to quickly run through some of the AWS machine learning services. And then I'm happy to answer as many questions as I can in the time remaining. So we'll just jump straight into it. So at AWS, we have a really simple mission, a mission I really like with machine learning, and that is to put the capabilities of machine learning in the hands of every developer. What that really means is simplifying and removing a lot of the undifferentiated or difficult tasks away from people so more people can use machine learning. So if we take a look at the machine learning stack, we think of it in 3 layers, broadly speaking. And each of these layers is targeted at more of a persona and a problem space. So if we take a little look at the first layer, we'll have an understanding of where we start with that. So the first layer is at the frameworks and infrastructure layer. What we really mean here is this is typically used by the machine learning experts. These are the expert practitioners that want to be very hands-on with some of the latest machine learning open source tooling, such as TensorFlow or PyTorch or any of the other open source tools out there. Keras is another great example as well. And they typically use the deep learning containers or the AMIs. They want to have full control of the GPUs and CPUs, and they want to have this infrastructure on demand and scale up when needed. Now, of course, many of us are not machine learning experts, and we perhaps come from a more of a developer background. That's my background as well. And that is particularly interesting for people, and the ML service is particularly interesting for people that fall into that group. And broadly speaking, the main product to be aware of here, or the main tool to be aware of, is Amazon SageMaker. And what this does is it wraps up together the flow of when you're building, training, and then deploying a machine learning model into production. So it gives you an interface that you can use that will look like a Jupyter notebook. You can write your code, you can write your comments, you can explain what you're doing, you can do experiments in your data processing. You can also capture some data using ground truth, and this allows you to bring in data, label it, do predictions on the label, and then see if this can be used for training data further down the lines. There's also the marketplace, which instead of needing to build your own models, you can take models that are already created off the shelf, that have been proven, and bring them into here. And SageMaker Studio, or the IDE, then gives you almost like a developer environment that you can design, edit your notebooks, the algorithms, you can run experiments. And when you're ready, you can train a machine learning model. And you can attach this to any of the data that you have stored away in AWS, in any of the different data sources, or even external sources as well. And you can apply whatever compute you need to it. So in some cases, you can use a single CPU, or perhaps you need to scale up to multiple CPUs or even GPUs. It's all there at the tip of your fingers. And once the model is trained, you will be able to monitor the performance through the console as well. You can see how well the model is performing. And then when you're ready, you can decide to deploy this model out there into production. And this tool is great if you have a use case where you need full control over the data that is being trained on, and it's a specific use case of the problem you're trying to solve. So I'd really encourage you to take a look at that if you fall into this particular scenario. Then the other set of services to look at is the AI services. And with the AI with the AI services, what we're really talking here is these are a set of services that are designed for application developers, or developers that aren't aware of how machine learning algorithms work. After all, many people want to be able to have the power of machine learning by just calling a simple API. And this API can then accept and input your data and provide you with a response, the predicted outcome. This is particularly useful for adding human-like characteristics applications. the ability to see, recognize entities or people or activities inside of pictures or videos, to hear, to take this audio and transcribe it into text, or to take audio and then speak it. You can translate that as well. And also you can take contents of data and extract meaning from it. One of the very interesting services, particularly for this hackathon, is Amazon Comprehend. And that allows you to take medical notes that are written with a very specific language and domain information and extract structured data from that. And this then allows you to run queries, traditional SQL queries over the top of that data. It gives you a JSON response. And there's many of these services that the models are pre-trained. You don't need any data. You can just send your request and you get your response back out. Another one that could be particularly interesting is Forecast. And Forecast allows you to run predictions on time series data. So if you were trying to predict how popular a particular item was, or how much energy you needed, or what your workforce is, or cash flows, you can use Forecast to then build sophisticated predictions that are more accurate than using traditional statistical models, because they take into account the wider context that's available, not just what's inside the data. So you think of all that external data, external information that's happening outside of the data you originally collected. And so these are the main areas within AWS when it comes to machine learning. So I'd really encourage you to take a look at these and try and understand, what can I use? Typically when I talk to developers or startups, I say try and start with the the AI services. These are all pre-built. You can quickly wire them up to your application, take advantage of all these different types of functionality. And if not, then drop down into SageMaker and build models based on the data or the use case that you need to. I just want to end this really short talk before we jump into the questions with just a few key resources that are some of the resources that I really like to share with people in general, and some other resources that are specific to what's happening right now. So the first link is will take you to the page where you can see all about the different services. You can get hands-on. There's lots of training. There's even ML University for later as well. There's a data exchange. All machine learning algorithms need data if you're going to train them yourself. And here you can find relevant data that could be useful during the course of this weekend and in the future. One of the other things I really encourage you to take a look at is Papers of Code. They've done a great job of categorizing all the machine learning algorithms by use case. So you can take a look at the use case that you're trying to solve. You can find the paper that relates to that use case, and then the code implementations, and you can take these, bring them into SageMaker and train it on your own models, or sometimes even come with a pre-trained model as well. And the final two links are all the resources for the activities and projects and people building applications to help tackle the COVID-19 crisis. So now I'm going to open the floor up to questions. So please, if you have any, or drop them into the, just ask them through the chat. And here we have the first question is around the AI services layer. Someone is asking, is there some way that you can use it to build recommendation systems? And one of the services that I did not actually touch on as much detail, but I'll just explain it now, is Personalize. And Personalize is built with the same technology that we use internally to power the website and some of the other personalization aspects of the retail site. And what that does is it gives you the ability to create a different experience for all your users based on the data that's available to there. And this is typically another way that you could describe a recommendation engine. So I'd highly encourage you to take a look at the recommendation engine that's available there. And this is where so there's two different ways you can approach building a recommendation engine. One is by using a service like this, or by taking a model and extracting the features and seeing what people would like the most. And you see many examples in movies. And the other one is where actually it's not necessarily the product that makes it similar to people. It's how I am related to somebody else, or how this product is related to somebody else. And that's where I'd encourage you to take a look at graph databases, and Neptune can give you a good example. But definitely start with Personalize. So the next question we have is from Alessandro, and he's asking, they have an application that's related to a specific lens, so they can take different observations of the eye and then set them to an AI algorithm. And asking if AWS could help us parallelize this service. So one of the really useful things about the cloud is we have different types of resource at your fingertips. So we have people that are able to take applications and then run it across as the many instances as they require to, and they can scale that up and down. And this is really the most common technique for that. So when it comes to answering the question of can you parallelize it, it largely depends on how it's been built. So if it was built and there's no state, and you just need to fire requests and responses, you can then deploy this onto a single instance or a single container, put that in an auto-scaling group, and as you send more requests to it, it'll either scale up the resources, and then when there's less requests, it'll scale down the resources. If you're able to fit it inside a Lambda function, you can do this without using any servers behind the scenes as well. And if this specifically is an AI algorithm, then you can take that and you can put it into SageMaker, you can train it through SageMaker, and you can deploy it in SageMaker, and it'll do that all for you as well. I have a question here from Ashkan. Apologies if I pronounced your name incorrectly, about scenario planning. Is it possible you can just respond a little bit later on with a little bit more what you mean? I'm a bit unsure if that's okay. Then, yes, so we have a question here, someone asking, can you combine a service, an algorithm that you've implemented with one of the off-the-shelf algorithms from Amazon? So that come with Amazon SageMaker. So what I'd say about the Amazon SageMaker algorithms, they are based on existing algorithms that are out there. So, and they've really been optimized to work easily and more efficiently inside of the cloud. So you'll find similar performance from other algorithms from an output point of view, if that's what you're looking for. What I do tend to see is people combining algorithms so that they are an input to another one. So you quite often see this where it's a complex flow of actions. And a better approach, rather than trying to build an algorithm that can answer almost any question, is to build algorithms as microservices to answer one small question. So to kind of bring that to life a little bit as an explanation, is that you would have an algorithm that would accept an input and then decide what algorithm to send it to. So if you were trying to personalize an experience for somebody, for example, and someone was asking you for one particular product range, you perhaps use the most appropriate machine learning algorithm to answer that question. And this algorithm in front can be used to do that. Another example that I've seen some startups do is really quite interesting is if you're trying to use question and answer, there's the BERT algorithms, which are very sophisticated, and they're able to extract meaning or the most relevant answers that you would expect to see from a given question. A little bit like what you might see in the search engines as you type, it might take the most relevant piece of the search page and bring it to the top. This is really a really great solution. However, it's very process intensive. So it's often impractical to run that over your full data set. So sometimes you can put an algorithm in front of it that will collate a smaller subset of candidate responses and then use this more powerful algorithm to pick the best one. Just reading through the next question. So yeah, one of the questions was, so personalized is more targeted to retail customers, and then how could it be used outside of that use case? So the way that it's explained on the website largely is around retail, but if you can think of personalization as a tool, and in our case, we've used it very extensively inside of retail. And one of the examples, the most common or classic example is if you've bought this item, or customers that have bought this item will have also bought this particular item. But that concept exists in many different scenarios, whether it's recommending which movies to watch or which restaurants to go to. So that concept can exist as a tool. So try and think of it as, does this particular item fit my use case? Now, there are some nuanced use cases where the similarity between products will not give a satisfactory result. And that's where you need to think about what is the reason why this product is related to another product. Is it something that I can extract from the actual product information, or is it something that I can extract from the relationship between the person and the other person that used it, or the entity that's consuming it and the other entity that's consuming it? If it's on the first side, I would suggest that personalized or recommendation engines in general are able to use this. And if it's on the second side, that's where you want to take a look at using a graph database and modeling the entities. Personalized comes with some additional data sets and models tuned for retail or that type of use case, but I really encourage you to take a look as well. So just taking through to see if there's any additional questions. So if you have any questions, please drop them in. Yes, so someone's asking if there are any examples of using Lex to build chatbots and how easy it is as well. So what I suggest you do is take a look on GitHub, so GitHub/AWS Labs. We have a lot of examples for using Lex and many other services available to you. And I actually built a chatbot during a hackathon a couple of years ago, and I found it particularly fun and also very easy. The Lex makes it simpler than most cases because what you need to do is you need to capture some sample phrases. So the classic example we tend to use is about catching a flight, which obviously difficult at the moment, but you would provide the slots that you need to. So if you're looking for the time, the origin, and the destination, then you would provide some phrases that capture this. And you provide some phrases that capture just one of the entities, like I want to depart from London. And then it allows the model itself will then create different variations of all these phrases. So give it sample phrases, but make them sound quite different. Think about the different ways people could or may ask for a particular item. And then whatever is missing from that original phrase, it will then ask follow-up questions to capture that for you. You can then present this as a text chatbot, or you can link it with some of the other services, such as Polly, which takes text and speaks it out, or Transcribe, which will listen to the text and then, listen to the voice and then transcribe that into text. It seems to be a follow-up question on the DB graph tool on the AI services layer. So the graph database is actually not a class as an AI service, it's classed as a database service. And this database that is specifically for graph queries is called Neptune, and you'll find that under the databases part of AWS. And the reason is although it can do recommendations, it just approaches it from a very different approach because it looks at the first order, second order, and third order relationships between an entity to see how somebody would want to use that in the future. So I had another question about how to distribute pre-trained models over auto-scaled instances. So typically, a model will have an input and then provide an output. So you can think of it like a request response pattern, almost similar to what you'd have in a website. It's just the compute will have a very, very specific compute profile. It could be very intensive CPU, it could even be a GPU. So in this scenario then is depending on how you communicate over that, if the model allows you to communicate over HTTP or TCP, then you can do this simply. If not, then what we see people doing is building a very thin layer in front of the model to capture that input communication, whether it's TCP or HTTP. And then what you would do is you would create these instances and put them in an auto-scaling group. And that auto-scaling group would listen on either HTTP or TCP and then capture the responses and then distribute them evenly between the instances behind the scenes. One of the easiest ways of doing that is taking a model that you've already built and having SageMaker deploy that. And that's another possibility as well. So I'm just taking a look at some of the other questions here, just to catch up. Yeah. Okay, so one of the questions that's been asked here is how can you use the forecasting in different scenarios, and then so I'll read the full question out. So regarding market trend forecasting, in order to establish different scenarios, how could you use AI and machine learning to capture insights on the market and the macro and micro trends? So with personalized, what you can, apologies, with forecast, what you can do is you can take your data of your previous values that you understand, and then you can add additional contextual data to other constants that exist in the world, whether it's weekend or weekday or categories. And what then you can take a look at is one of the important things is it's not just getting an answer like a point forecast, it's getting a range of different scenarios that you're able to model and then understand based on your inputs what is the correct action you can take. Because if you think of the scenario where under forecasting, as in not having enough resources in place, is very problematic, you would want to have some ability and control to adjust the forecast to take that into account. But on the flip side, if you have a forecast that is grossly over-resourced, then you have a lot of wasted resources. So with this, with forecast, you're able to choose to model the different scenarios so that you can make the most informed capacity of forecasting decisions. So that's something that the tool will allow you to do. So we have a question here about how to go about creating a proper machine learning procedure after doing unsupervised machine learning. So if I'm understanding this correctly is how to build unsupervised learning pipelines. So there's a couple of approaches to this. There's reinforcement learning, and this is where you create a scenario or almost like a world, and then you figure out what the reward function is, and then you have the model will go around and train itself against these different scenarios and see what the outcomes are and adjust its weights. And inside of that, that's something you can do inside of SageMaker as well. The other approach is if you're trying to take unlabeled data and then build a model. So for example, you wanted to categorize text, but you didn't want to label the text, and you want to put it into different buckets to say that this bucket is similar to these 10 buckets, and figure out which is the most appropriate piece of text to go into that. And this is something that largely the models will take care of. So when it comes to training the model, the scenario is very similar. It will go through the data set multiple times with each iteration of the data set, or an epoch. And each one of these will adjust the weights at the end of it and then compare it against known data to see if it's correct or not. And this flow is broadly similar for trained or supervised or unsupervised learning. So SageMaker will approach it in a very similar approach. You can take a look at some of the unsupervised algorithms that exist inside of SageMaker and see how they work. There's also some really good examples that show notebooks, and they will talk you through how things are done. And many of these examples also include unsupervised learning algorithms as well. So someone was asking about, what have we looked at as an Amazon? I'd really encourage you to take a look at the fourth link on there, the cord19.aws, and you'll see a lot of the work that we've done and what the startup customers that we work with has done, or even other customers as well. And you see some really, really impressive work that's been done. I'd encourage you to take a look at that. So just read another question as well. So if an instances have been auto-scaled and they don't share memory, and if you cache or train a model and save it to a file, it'd be nice to share this cache result with other instances. That would reduce the computation time for other instances as well. So just trying to understand the question fully. So each instance, if they're not sharing memory, the person asking the question is absolutely correct. Whatever has been cached will not be available to the other instance. Typically, the individual instances themselves don't tend to need to be aware of the result of an existing model to do a prediction. There will be this scenario, which I think he's referring to, or I think they're referring to, which is around, well, if I get the same request and it's already been calculated by a different instance, this one, if it goes to another one, how will it know? In that scenario, you have a couple of options. You could either use a cache like Memcache or Elasticache. So within Elasticache, you can have Memcache or Redis, and in this way, you can actually have the cache shared between instances. But I would actually encourage you to take a slightly different approach. If you've got this behind a load balancer, you'll have like a JSON response that comes out, and you'll have a JSON request that went in. And you can then use caching on the web layer or within the API HTTP protocol, which is a really well-established way of caching results. So if you know that this result will not change for a period of time, or if that value is this, then it will stay the same, at least until you retrain the model or give it some more data, you can mark it that way. And you can either use a cache expires as the time, and then invalidate it when you train the model, or you can use e-tags, which are a way of expressing the hash result, the hash of the result, and then it compares it against that. So I'd encourage you to take a little look at that approach. And so if anyone has any more questions, we still have a few more minutes available.
Thank you very much, Rob. There are no further questions coming. A lot of questions regarding the video, the session, the webinar. I recorded everything and it will be uploaded on Slack in the overall channel, so it will be available for everybody. We'll try to do this as soon as possible in the course of the day, evening. Yeah, thank you very much once again, Rob, for the great webinar. Thank you very much for the participation. Good luck with the challenges, with the solutions that you're developing, and we're very excited about the results tomorrow and on Monday. Have a great afternoon.
Thank you all for your time, and best of luck during the weekend.
Bye-bye.